Okay, this is the first page of the scientific notation word problems test review. As I promised, I would put the key up for you. So on just your really basic ones, if you take 1.9 and multiply it by 2, you end up with 3.8. And if you take 10 to the negative third times 10 to the fourth, you actually end up with 10 to the fourth over 10 to the third, which is 10 to the first. So it equals 3.8, because you should always have something in the ones place, just a single digit, 1 through 9, times 10 or 10 to the first. Okay, let's go to number 2. Same process. We're going to go 9.2 times 4, which equals 36.8. This is going to require another step. And then we have 10 to the fifth times 10 to the negative third, which is in fact 10 to the fifth over 10 to the third, using the negative exponent property, which ends up being 10 to the second. So you start off with 36.8 times 10 to the second, and therein lies the problem. It should be 3.68 times 10 to the something. I always do it like this. I've got 36.8. It's got to go 2 decimal places to get to that decimal, but I need it to be 3.68, so I know I have 1, 2, 3 spaces before I go to that decimal point, so it's 10 to the third. This is the proper answer, 3.68 times 10 to the third. You'll get some credit if you can get even part of the way there. This one got moved over, so just ignore this 4. These are division. 5.5 divided by 5.3 gives you 1.04. Again, you're doing these on your calculator. You have 10 to the negative 1 divided by 10 to the second. 10 to the negative 1 comes down using the negative exponent property, so it's 1 over 10 to the third, because you have 10 to the second and another 10 to the first is 10 to the third. But in scientific notation, we use negative exponents. 1 over 10 to the third is the same thing, or equivalent to 10 to the negative 3. So it's going to equal 1.04 times 10 to the negative third. Again, it's only with scientific notation that we use negative exponents. Otherwise, you're required to write them with positive exponents. On number 4, it's 2.04 divided by 2. Again, you're doing this with your calculator, which equals 1.02. And then 10 to the negative 1 over 10 to the negative 2. You're going to use that negative exponent property to get positive exponents, so it's 10 to the second over 10 to the first, which equals 10 to the first. So it equals 1.02 times 10 to the first. Okay, now let's go ahead and go to the first word problem. Move this down a little bit. It says the speed of light is 3 times 10 to the 8th meters per second. If the sun is 5.791 times 10 to the 10th meters from Mercury, how many seconds does it take light to reach Mercury? Express your answer in the scientific notation. I'm going to actually do it both ways just so you can see how this works. So you got to use your distance equals rate times time formula. Your distance is this right here, and that should be a capital for the sun, and yeah, because it's our sun. Okay, so the distance from the sun to Mercury is 5.791 times 10 to the 10th. And it equals the rate of light, it's how fast it's going, is 3 times 10 to the 8th, and that's going to be times time. So distance equals rate, speed, times time. We divide both sides by 3 times 10 to the 8th. You could also just rewrite the formula. That's another way to do it, where you just divide both sides by rate to get time, and you'd have distance divided by rate equals time. It doesn't matter. These become 1. You're left with time. And you simply take your 5.791 divided by 3, which gives you 1.93. And your 10 to the 10th divided by 10 to the 8th. And we do 10 to the second. So it's 1.93 times 10 to the second is your time. Now, that doesn't really make a lot of sense, and it's not a very big number. If you were to go 10 to the second, it would move the decimal 2 places, which means it takes, this answer is fine. You would need to write what you're talking about. This is seconds. Let's finish that first. 1.93 times 10 to the second seconds. But it would be better if you wrote it takes 1.93 times 10 to the second, or 193 seconds, for light to reach Mercury from the sun. Alright, so there you go. That's the better answer, but if, as long as you put seconds here, I would accept it. Again, I did say to write it in scientific notation, but I thought in this case it would make more sense to also think about what does that mean? What does 1.93 times 10 to the second mean? Okay, now we're talking about the half-life of uranium, 234, which is 2.5 times 10 to the 5th years, and the half-life of plutonium is 8 times 10 to the 7th years. You can see that plutonium has a half-life greater than uranium. It wants to know how many times greater is the half-life of plutonium than uranium-234. You need to label. It doesn't need to be extensive. You could even go P and U. I'll just do a little bit more since we're putting this in our notes. Plutonium over uranium. Labels are very important. So you want to know how many times greater, how many times will uranium go into plutonium, divide into. So it's going to be 8.0 times 10 to the 7th, that's plutonium's half-life. And then uranium's half-life is 2.5 times 10 to the 5th. So 8 divided by 2.5 equals 3.2. 10 to the 7th divided by 10 to the 5th. You have more in the numerator, so it's going to be 10 to the second, so it's 3.2 times 10 to the second, and that's times greater. That would be a very bare bones answer. It would be better if we wrote a sentence so that people really knew what we were talking about. So plutonium's, and I'm going to write it, I'm going to pause this for a minute and write it. So plutonium's half-life is 3.2 times 10 to the second, or 320 times greater than uranium's half-life. Now I'm going to need you to watch the other recording to be able to see the last problem, which is the ratio of the Milky Way radius. It's on the back side. So if you'll go ahead and watch that one as well, then you'll get all of the word problems, and because you will have some scientific notation word problems on your final.